Okay, so I mean, I'll start with 6 if you guys, okay. So this is saying, and I mean, for those of you who have a book, that's on page 397. Maybe you can share, possibly.
That's my book. Okay. This isn't the right one, right?
Yeah, that's Kaplan.
Alright.
So yeah, it's the CollegeBoard one.
Alright.
Okay, so it says in the figure above, AB equals CD. So they're saying the length of like these two line segments are equal. And then what is the value of T? So I mean, you can see, the B coordinate, and that's basically got, so it's -2 comma T, and we're trying to figure out, basically, we might want to start with figuring out the length of CD. So then what do you think the length of CD is?
It's 10.
Yeah, it's 10. Great. So then, if we look at, this line AB, we see that A starts at like y coordinate 3. So what do we think T is going to be?
T is -7.
Yep. Okay, great. Good. Does that make sense to everybody? What? Like this question?
Yeah.
Yeah, I mean, not really. It's
it has
like
to do with the
coordinate.
points.
Yeah, I mean, it's like
Just
coordinate
geometry.
geometry, sort of. I mean, it's more just like coordinate systems. Yeah. Okay. Did anyone have trouble with 7?
I got 7.
Okay, you said you got it correct?
Yeah.
Yeah, I mean, I think 7's pretty straightforward, so maybe we should go to 8. So, and this is kind of one that, starts getting a little more tricky. So we basically have these circles, and they are tangent and all that, and now they kind of just give us the radius of the various circles, and we want to find the radius of the big circle. So, I mean, if we have kind of, and then, so, I mean, they're telling us the radius of circle A, which is the middle small one, is 2. And they're telling us that the radius of like these two circles is 4. So how do you think we can find the radius of the big circle?
So we make the circle on the right 4 multiplied by 2 to get the diameter of that.
Yeah.
And just add the two
Yeah,
numbers.
so I mean, does everybody see that? Here, I'll get a different color. We can basically, draw a line here. That's going to be 4, and that's going to connect it. So then we just, this is now the radius of the big circle, so we can just add them all up. Yep, okay. So it seems like you guys are doing well. Did you guys have trouble with 9?
I didn't.
Okay. Yeah, I mean, I think 9's pretty straightforward, but let's look at 10 because that's a pretty, I think it's, somewhat simple, but for people who haven't had too much geometry experience before, it might be, a little bit more difficult. So, I mean, we're basically given, all these angles, 110 and 30 and 70, and then we're also given a right angle, right? So does anyone know how we would find that last angle x?
So what I did
Kind of
was
the
I just wrote in 90 because that's what a 90 angle is, and then I just added 90, 110, 70, and 30. And I subtracted that from 360. So then I wrote 60.
Yeah, okay, so then but then we have to find x, right?
Right,
And
so
then,
then it's just
yeah,
60
then
plus
you add
70.
70. Does everybody get that? Okay, great. So yeah, we're just, that's just a good thing to remember that the angle around is 360. So we're going to, whenever, we have kind of this arrangement where they're all together, or, it's also good to remember when we have a straight line, then they add up to 180, and we can always use that to our advantage even more in more complicated math problems. Okay, 11. Anybody have problems with 11?
Yeah, I skipped it. I couldn't.
Okay. Okay. So this one is kind of one of the like SAT math like tricks sort of. Like I mean, if you've never done one of these types of problems before, it might seem kind of like crazy or weird. But basically, so we just want to kind of figure out like we want to plug in numbers essentially. We want to find a value for k that makes sense with this problem and then kind of just work from there. So they say when the positive integer k is divided by 7, the remainder is 6. So what can we just pick a number for k then where this rule is true? If it's divided by 7, the remainder is 6. So I mean, one thing we could do is we could take 7 and we could add 6, right? And then we could get 13. and then 13 divided by 7, the remainder is 6. So I'm just taking what it's divided by, and I'm just adding the remainder. And I mean, of course, there are going to be all kinds of multiples too. If you take, 14 and then you add 6, you're also going to get something that follows this rule. But the easiest way to do it is to just, take 7 and then add 6. So you get 13. And so now they're saying, what is the remainder when k plus 2 is divided by 7? So again, if you don't like plug in numbers for this problem, you're going to be pretty lost, right? Like, well, this is so abstract, k plus 2, what are we doing here? But now we can just take 13, right? And we can just add 2. So that's 15. So then what is the remainder when 15 is divided by 7?
1.
Mm-hmm. Yep. Did anyone have problems with like number 12? I mean, numbers, but if you haven't seen like graphs, then everybody okay with it?
Yeah.
Okay. So what about, let's look at number 14. Or actually 13, you guys are okay with, sequences or not really in number 13? Okay, so let's go, so let's go to 13. So they're saying the first term in a sequence of numbers is 1. And then each term after the first term is the product of -2 and the preceding term. So let's kind of look at that. So our first term is 1. So then what's our next term going to be if we multiply -2 by our preceding term? Mm-hmm. And then what's our next term going to be?
4.
Mm-hmm. Yep.
16.
Mm-hmm. Mm-hmm. Yep. So I mean, we're just writing out, the sequence and just using that rule. Now we can, later on we'll see, as we go through these tests, we'll see more complicated like sequence and series problems. But this one's kind of basic right now. So we've just got, we're just going to literally multiply each preceding term by -2, and that's it. Okay, great. So number 14. I mean, that one's kind of straightforward, but did anyone have problems with that one? Hi. And we're basically, for number 14, that's kind of difference of squares, right? So we're going to just multiply that out, and we're going to get, what are we going to get?
4x squared minus 25
Mm-hmm.
5.
Yeah, and then we're just going to solve for 4x squared. Yep. Is that clear to everybody? Yeah? Okay, great. Okay, so what about 15? And this is, again, just kind of a simple, like line algebra problem, with slopes and everything. Did you guys have trouble with it at all?
I got it down to A and B, and then I guessed correctly.
Okay,
totally
sure,
how I got
sure.
It. I mean, what I did was, I know it had to be negative because it's sloping downwards,
Yeah.
but then put it at A or B, and then I guessed
Right,
which one it was.
right. So exactly. So I mean, it's sloping downwards. So we know that the slope is negative, right? I mean, you guys remember, like all of you other guys remember that from like algebra? Yeah. Okay, great. So then we're just going to look at now. The key here is to kind of look at. They're saying P is greater than R. So what that tells us is that the x, like, they're basically saying A is at P comma R, and they're saying that P is greater, the absolute value of P is greater than the absolute value of R, which means that like A is farther in the x direction from the origin than, in the y direction. So if we think about our slope formula, then, if we were, we can even pick numbers if you want. Do you guys want to pick numbers? Does that sound good? I mean, so you could kind of think about it in your head and be like, oh, well, basically, rise over run is going to be difference in y over difference in x. So, I mean, if the difference kind of, if this y coordinate is smaller than the x coordinate, then we're going to have a slope less than 1. So that's why we get -1/2. But we could also plug in numbers and say, okay, so, A is at, -3 comma 2, and then just do the slope formula, like, with respect to the origin. Does that make sense? Okay, great. So now we're starting to get into, the harder section a little bit, right? I mean, 3a plus 4b equals b, this one, number 16, I mean, we're just going to subtract b from both sides. And then we get 3a plus 3b equals 0, right? And then we just, so I mean, obviously 6a plus 6b is going to be 0. Make sense? Okay. And then, so 17, did anyone have problems with 17? I mean, it's a little bit of a tricky geometry question. Okay, so let's go over it. So basically, the kind of key information they're giving us here is that, F and E, or well, F rather, but I mean, you probably assume E also. F is the midpoint of BC. So do you think that we can like assume anything from the fact that F is the midpoint of BC?
So we assume that BF is equal to FC, right?
Mm-hmm. Yeah. So what do you think, BF or FC is then?
They're both 5 square root 2.
Right, so they're both 5 root 2. So, I mean, basically now all we have is this triangle. Oh, sorry. We have this triangle that's got 5 square root 2. And then do we remember, we can look back at our formulas here for special right triangles. And we basically see that, 45, 45, 90, S root 2, right? So, I mean, now we can basically assume that this is 5, and this is 5. And, it looks symmetric and everything. Again, like, you could, a lot of people, who are like really super rigorous with math and everything, like they want to like prove exactly, but I mean, you can kind of, you don't have to sit there for, a minute or two wasting time in the test being like, well, can I prove this is exactly symmetric? I mean, you pretty much know it's symmetric because you've got these two 10 root 2 sides, it looks symmetric, so I mean, just kind of assume that and move on. And so basically then, now we know this is 5, and so then we can just do basically 5 times 10 and get the area of the rectangle. Does that make sense? Okay. So now we have functions. So I'm going to go over 18 because I'm pretty sure most of you would probably be pretty confused about that one. Just because functions are a big part of the SAT and they're pretty hard to like, if you haven't had a lot of practice with functions, they can be kind of hard to grasp. So I mean, do you guys understand like what this means?
Yeah, I mean, so there's a function, and then for the value of x,
Mm-hmm. Yeah, so I mean, basically, and it's basically the same thing as like, it's almost the same thing as y. So you can basically assume, and I mean, really what it's saying is like, if you have f of x, equals x squared, and then you have like f of 2, that's basically saying, well, what is y when x equals 2? And we would just plug that in then. So whenever we see something like this, we're always just going to put like, the 2 where the x was. And so like wherever the x was here, we're just going to, we're just going to take this number, or, even if it's a variable, like, f of a, we're just going to put a right where the x was. So and that's all we're going to do. We're just going to replace all the x's, and if we had some crazy thing like f, we'll say g of x equals like, x cubed plus, x plus 3 or something, then g of 2 is going to be 2 cubed plus 2 plus 3. So we're just always going to replace, with like, look where x is and then replace with 2. So I mean, here they're giving us a table. And the function questions on the SAT pretty much come in like 3 flavors. You'll have one with a graph, and then or you'll have one with a table, or you'll have one with an equation, and then, or some combination. Like this one's kind of like a table and an equation. So I mean, here they're saying, they're saying we have this equation, f of x equals k times a to the x, and we don't know what k or a are. So we kind of need to figure that out. Because they're asking us what the value of a is. So how do you guys think we should go about that? So we're going to look at basically using our table, because that's actually a table of like, x and y values for this function. So we're just going to pick some points and we're going to plug them in. So I mean, you guys have probably done, right, when you have like, y equals like 3x plus 2, and they've said like, oh, they're, like we want to find one point, on this line, or maybe you've had something like, y equals 3x plus b, and they're like, oh, we know the point, 2 comma 1 is on the line, so now find b. So all we need to do is just plug like this 2 in here and this 1 in here, right? And then find b. So I mean, this is the same idea, just a little more complicated. So we're just going to choose a point. And, let's choose like, where x is 0 and f of x is 1/2. I mean, you can really start with anything, but that's going to, I mean, points with 0, right? They're going to simplify some stuff. So that's a good idea. So let's put in 0 for x. and 1/2 for y. So this a to the 0, that simplifies to 1. So we get, k times 1 equals 1/2. So then k equals 1/2, right? So now we know our equation is f of x equals 1/2 times a to the x. So how do you think we're going to find a? We're going to find it, very similarly to how we just found k.
So we'll put 1 in for x, and so make it equal to.
Yep, we can do that. Exactly. So we have, we have the point, where x equals 1, y equals 2. So we're going to say 2 equals 1/2 a to the 1. So then, if we just kind of, algebraically solve this, then that's 4 equals a. And that's the answer. So this is a complicated problem, but I mean, really the thing about functions is just kind of, you're always going to be like picking points and plugging them in, or just kind of like, we'll get to some of them later on with like, kind of the graphs and everything, but it's the same principle. You kind of look at like the x value that they, a lot of times they'll be like, what is, here's the graph of like g of x, what is g of 2, and we just kind of, look on the axis and we just count like, okay, x equals 2 over here, and they give us this funky graph. Oh, let's just look what this value is. So I mean, it's always going to be the same thing, but it's I mean, functions is probably one of the biggest, like, kind of topics in SAT math that people have trouble with. So I mean, we should, I mean, I think we'll definitely encounter some more function problems, in this section. No, I mean, not in this particular section, but in like the next section in this test. All right. So let's move on to number 19. How did people do with number 19?
I skipped it.
Okay. Well, if you skipped it, we know the rest of the class is probably skipped it too. Okay. So basically, we have let me try to draw a pyramid. Okay. So they're telling us, okay, we've got all these crazy variables floating around. We've got m, h, and e. And I mean, notice how they say, right? They're like, oh, if e equals m. So I don't even know why they put e in the first place. Like, they're just trying to, that's just another like layer of them trying to trip you up. Because they're like, oh, well, here's e. Oh, whoops, we mean it's equal to m. So it's just stupid. So I mean, here's our diagram. This is m. And then this is h.
Yeah, when I attempted to solve it, I noticed e had nothing to do with it.
Yeah.
Like, it's just like,
Yeah, right? I mean, it's just another layer of them trying to, like, get you confused. Okay. So here's our question. And they, meet at V, okay, that's the, like pointy part of the pyramid. And they each have length E equals M. Okay, what is the value of H? So we've got to kind of do some pretty intense, like, triangle stuff here. And I mean, that's pretty much, when you see a pyramid, the pyramid questions are not that common on the SAT, but you'll always be working with triangle stuff whenever you see them. Okay, so we can draw a line here. And so I mean, first of all, what do you think this length is? It's okay if you don't know. Let me draw, like, actually this marker's hard to erase. Let me switch to a different one. Oh, no, that's okay. All right, so we're gonna look head on. I'm just saying, like, I'm just looking at the base of the pyramid right now.
looking down at it.
Yeah, like, I mean, just kind of, or, looking up at it, just kind of looking at the base. So we have M, we know it's a square base, right? And then we have this line here. And so let's look at our special right triangles again, right? And we see, okay, that, it looks like, and by the way, anytime you draw a diagonal in a square like that, you're going to get 2 45, 45, 90 triangles. And that's just geometry. But anyway, so we have 45, 45, 90 triangles, right? So we know that this diagonal is m root 2. Okay, good. So now if we're just looking at, to find h, and again, this is kind of like a spatial thing to recognize, but I mean, you see kind of like this, here, let me maybe draw it in red. But I think you guys probably see what I'm going to say, like, have this triangle, right? And that's the one we kind of want to look at to find h. So Do we know, I mean, obviously we know that this like hypotenuse is m, but do we know what this length is? Now that I've kind of done this, do we know what this length is?
So
It's going to be half of
Right, exactly. It's going to be m root 2 over 2. So we have two sides, and we want to find this third side. So whenever we have a right triangle and we have two sides and we want to find a third side, what do we do? No? What? You look like you're nodding, but I guess. Yeah, exactly. So we use Pythagorean theorem. A squared plus b squared equals c squared. And remember, this is always going to be the hypotenuse, right? So here, we're going to write h squared plus m root 2 over 2 squared equals m squared. I'm just plugging in, this is h. Actually, can you guys see this at all? Okay. So I mean, this is h, and this is m root 2 over 2, and this is m. So we're just plugging all of that in. Yep. Okay. Great. And now, I mean, now it's just a matter of solving, right? But I mean, we can, go through it really quickly. H squared plus 2m over 4 equals m squared. So this is squared, and then, we're just going to subtract. Right? All right, awesome. So, I mean, that's one of the most difficult problems. So let's look at 20. And 20 is not difficult, but they're using a kind of percentage trick. And with percents, you always want to be careful because they're going to be tripping you up by like kind of saying either, some variable k is a percent or a decimal. So like they might say, k is a percent, in which case, it's like 50, or, k is a decimal, and it's like, 0.5. So, I mean, I always find it easier to work with decimals. So, I mean, I would kind of just do the problem with, like, assuming it's a decimal and then look back and, like, make it a percent. But, I mean, if you guys feel comfortable with percents, like, just right off the bat, that's fine, too. I just feel like, you always use decimals in math when you're talking about percents. So it's good to, like, just use it this way and then convert back. Okay. So here they're telling us a salesperson's commission is K% of the selling price of a car. Which of the following represents the commission in dollars on two cars that sold for $14,000 each? So first of all, how much did he, sell?
28,000.
Good. And then now he gets K% of it. So if we were talking about a decimal, if K were a decimal, what would we write?
You just write 28,000K.
Right, we just write 28,000K. But now they're talking about a percent, right? So we need to take away two zeros, right? Because like when we convert from decimal to percent, we, go back and forth with two zeros. Yeah, exactly. So that's the answer. So I mean, this is a simple problem, right? But it's just, it's just kind of like it's so silly, but it's just remembering like, converting basically back and forth from percents and, remembering that. So I mean, it's not like conceptually difficult, but it's just kind of like trying to trip you up on something really simple. Okay, so let's turn to section 7. You guys can see the board from over here? Okay. All right.
This is probably my best section of all the math ones.
Okay. Okay, good.
I like it better than the first one.
Yeah.
It wasn't good enough.
Yeah, I mean, I feel like this first section was pretty difficult.
Yeah, the first section
yeah.
was really difficult.
So, I mean, especially the pyramid problem. I mean, I tutored a guy, who's getting like near 800s on the math section. He was like, he did not know how to do the pyramid question. He was like, I don't know what I'm doing here. So, Okay. So, I mean, again, I'm just always gonna in class kind of skip to the middle sort of because I mean I know you all are pretty smart and probably getting the easy ones right. But I mean, is there anyone in particular that you want to start with? I mean, did anyone have trouble with like 3 or like 4, or should I just skip to like 5?
I got 3.
Yeah, that wasn't hard.
Okay, good. So then everyone pretty much got 3 and 4. What about 5? Did people get 5?
No.
Yes.
Yeah. Okay, good. I mean, some people have trouble with 5, but
Yeah.
okay. No, you got it, or
No,
you?
I did not.
Oh, okay. Yeah, I mean, let's just go over that really quickly, just because circles are, you'll see probably at least 1 or 2 circle questions on the SAT, and like, really the thing to remember, the golden rule of circles is like, think of fractions. So you're always going to say like, oh, so I mean, here's an example that comes up that's not this problem, but I mean, they'll always do something like this, and they'll say, oh, this is like 30 degrees. And they'll give you like, the radius is like 6. What is this arc? And so really what you need to do is you need to say like 30 degrees over 360 degrees. And that's going to give you what fraction of the circle it is. And then from that, you can just do like, 1/12 2 pi r, right? And so then just plug in, what you have for r. So I mean, really, whenever you're dealing with like sections of circles, you're just going to do fraction stuff. So I mean, with this one, we see that basically the fraction is 1/4, right? So it's going to be, to find the area of that shaded region, we're going to do 1/4, yep, pi r squared. And then what is r here?
R is 1.
I mean, do people see that? Like, if we look at the square, and they're saying that one side of the square is 2, then if we draw a diameter here, right, then this is going to be 1. Good. Okay. So I mean, that's basically what we have, and then we just need to plug it into here, and we're done. Okay. So let's look at, well, I mean, probably, do you guys, like for number 6, do you guys remember kind of the rules about like perpendicular and parallel slopes?
I do not. I got this one wrong.
Okay. So for slopes, basically parallel, same slope. And that makes sense, right? I mean, if you have, here I'll use different color, if you have those 2 parallel lines, it looks like they both have negative slopes of like about like 1/2 or something, right? Okay, good. So, and then if we have perpendicular, lines, this is kind of the crazy one. It's the negative reciprocal. So that means if you have a line that has a slope of like 2, the thing that's going to be parallel to it is going to have a slope of negative 1/2. So and that's pretty much the only thing you need to remember. So I mean, but the other thing to remember is also always put your equation in slope-intercept form. So I mean here, yeah, exactly. We have x plus 3y equals 12. So I mean, we need to kind of put that in slope-intercept form. And how we're going to do that is we're going to solve for y first. Does everybody know that? I can just go through that quickly. We have x plus 3y equals 12, right? And then we can just basically, like subtract x. So then we get 3y equals 12 minus x. And then we can basically just divide everything by 3. So we get y equals 4 minus 1/3 x. So pretty straightforward. And then, so I mean, what's the slope going to be of a line perpendicular to this then? Yep. Perfect. Great. All right. Oh, so 7's a good one to go over. Do you know the rules of like what a triangle line can be? Like what the sides of a triangle can be, basically?
Yeah, this one I do know.
This one you know. Okay, awesome. Yeah, because I mean, this is something a lot of people forget. So, and the thing to remember with like sides of a triangle is basically, you know, with this base being 20, and this being like 5, this being like 5. Are they ever going to meet? The sides are going to meet? No. So you basically, the rule is you can't have any one side being greater than the sum of the other two sides. Or equal, right? Because if they're equal, you're just going to have a straight line. I mean, if you have like this is 10, and this is 5, and this is 5, right? Sorry, this is hard to draw a straight line that's actually trying to be a triangle. So I mean, if you draw that, right, it's going to basically just be a straight line because the two sides are going to lie flat. So that's basically the logic we use for this problem. I mean, by the same token, though, we have like this, and those are two sides of a triangle. We can't have, you know, basically we can't have the third side being less than the difference between these two sides, right? So if this is like 5 and this is like 20, we need a side of at least 15 because, or well, more than 15. I mean, if it were 15, it'd just be a straight line. Because if we have another side of like 3 or something, it's never going to reach either. So it's just a good thing to kind of draw out and look at, or you can just kind of memorize, like, you know, basically one side can't be greater than the sum of the other two sides. So, I mean, whatever you want to do, but you know, sometimes it's good to just draw it out and see. So I mean, that's kind of what we do here. So I mean, basically, you know, the side can't be like 10, right? Because then it would just be a straight line. It would be 5, 5, and 10.
So that's the answer.
Yep. All right. So, I mean, 8's pretty straightforward, but did anyone have trouble with that?
I got it wrong.
Okay. All right, so let's look at it. So, and this is kind of similar to question 3 in a way that we kind of have to like write 2 equations and stuff and kind of figure out, right? So, I mean, we kind of get this, you know, we kind of look and we say, okay, so candidate 1 received 28,000 more votes than candidate 2. Right? And then the second thing that we know is candidate 1 votes plus candidate 2 votes equals 28 million.
Wait, was it 2.8 million?
Right, right, yes. Wait, yeah, sorry. 2.8 million. So now what we need to do, basically, we just have these 2 equations, and we just need to, like, find the votes of each, and then find a percent from that. Does that make sense?
Mm-hmm.
I mean, you probably did that. You probably maybe just made
what
it.
I did was I took 2.8 million and I divided it by 2 to get 1.4.
Oh.
And then I added 28,000 to candidate 1.
Sure.
And subtracted 28,000 from candidate 2.
That's right, too.
Okay, that should work. So, I mean, did you get it right?
I mean,
Yeah,
I got
okay.
51% as my answer, and
Okay.
it was 50.5.
Oh, okay, so that must have been just a rounding thing. Yeah, I mean, I would go through the math, but I'm realizing it's like 135, and I want to get through some more stuff. Okay, so I mean, did anyone have trouble with number 11? No? And this is just a proportion one, right?
Yeah.
You're just going to set up some ratios. What about 12?
Yeah,
Yeah, I mean, 12 I think is pretty difficult. I mean, honestly, I don't want to say, like, if I were taking this test, I think I would have the most trouble with number 12. Even though it's not like, you know, at the end and
When you look at it, it doesn't look like it's that hard, but then...
Yeah, I mean, it's kind of really weird, right? So we've got this line. Okay, and then they tell us that basically, you know, AD is 4.5, and then BE is 3.5, right?
And CD is 2.
So what we want to do here is we kind of want to, you know, again, this takes some like insight and like kind of visual recognition, but we kind of just want to, you know, look at it and see if we can make any statements at all about what, like, you know, something might equal. So, I mean, like, just shooting in the dark, we can say, well, you know, 4.5 is AB, like, you know, AB plus BC plus CD equals 4.5, right?
Right, but you should eliminate CD because you know what CD is.
Right,
So you
exactly.
just make it AB.
Right, exactly. CD is
4.5.
2, so AB plus BC plus 2 equals 4.5, right?
And then you can do that with BE. Maybe
Right,
BC
exactly.
Plus DE equals 1.5.
Yep, exactly. So AB plus BC is 2.5. And then we can just do the same thing for BE. So that's BC plus CD plus DE equals 3.5, right? And so then again, CD is 2. And so we can just kind of subtract that. So BC plus DE equals 1.5. And remember this is a fill-in question, and they actually are saying what is one possible value. So we don't need to know exactly what it is. We just need to know, like, oh, what could a value of it be? So in looking at these two, like this equation and this equation, is there any value that like BC could not be?
Well, it can't be greater than 1.5.
Right, exactly. What if BC were 2? Well, that would work here,
Right.
but that wouldn't work here, right? Because, I mean, DE can't be negative. So, I mean, if BC, does everybody see that? Right? Over here? Okay, cool. So, I mean, if BC is basically, if BC is like 2, then DE would have to be like negative 0.5. So that's not going to work out. So, right. And so, I mean, can BC be equal to 1.5?
Yeah. No.
I mean, yeah, I mean, just how they have it in the answers and stuff, like, they don't want to say DE is 0 because then it's not like a line segment, and they are talking about like line segments. I mean, like, technically DE can be like 0.00001, but it can't be 0. So basically BC just needs to be less than 1.5 and greater than 0. So I mean, anything you put 1, 0.75, anything's fine. Just it can't be greater or equal to 1.5 or negative or 0. So yep, okay, great. So 13, did anyone have trouble with 13?
No.
13 was pretty straightforward, probably, right? Okay, great. So let's look at, okay, so here's another sequence question. Great. So in the sequence questions, too, kind of come in different flavors. Sometimes you get sums of sequences, and again, through this course, we'll encounter those. But sometimes we get sums of certain sequences. Sometimes we get, like, what we did, like, earlier today, where we're just kind of, like, calculating the 6th, like, term of sequence. Here they're giving us 2 terms. They're actually trying to tell us, like, well, what's happening. And, I mean, when they're telling us a sequence is greater than the term before it, and the difference in any 2 terms is the same, they're basically telling us we're adding the same number
Every time.
each time. Yeah. So we've got 17, and that is the 2nd term, right? Third term. Okay. So 3rd. So then we've got the 4th, we've got the 5th, and we've got the 6th, which is 77. So we note that the difference between, like, we kind of want to find the step, right? But to find out, let's find the difference first, and that's 60. And now, how many steps are going on here? 2? That's kind of what one would think, right?
3,
but let's,
right?
yeah, there are 3, right? Because to get from the 3rd to the 4th, we do 1 step. To get from the 4th to the 5th, we do 1 step. And to get from the 5th to the 6th, we do 1 step. So that's kind of what's going on here. Okay. So, we basically just do 60 divided by 3, and that's 20, right? So, basically, we're just adding 20 each time. Okay, good. So now, to find the 8th term, what do you think?
Add 20 to 77.
40.
Right?
Yeah, add 40, because this is close, but this is the 6th, so then the 7th and 8th. Yeah, exactly. So we need to add 40 to 77. Yep, and we get like 117. Great. Okay. Okay, so 15, 16, and 17, well, and 18, I guess. Probably a lot of people have trouble with these.
I answered 15 and I skipped 16, 17.
Okay, so 15 is just a trick question, really simple. A lot of you probably said 3.5, right? Maybe?
I said 2.5.
Okay, so it's 2.5 because there are absolute value signs. So, I mean, they're asking what the least value of x is. So then that means, right, x minus 3 could be negative 1/2 or positive 1/2. So we're basically looking for the least value of x, which is 2.5, which gives us negative 1/2. But then, absolute value signs make it positive 1/2. Does that make sense? Okay, Great. So let's move on to number 16. And I think number 16 is a pretty weird question. Anybody think that?
Yeah.
Yeah, it's pretty weird. Okay, so they're telling us there's this 4-digit thing, W, X, Y, Z. Good. And they give us these rules. So we have X equals W plus Y plus Z. And we have W equals Y plus 1. And we have Z equals Y minus, Z equals W minus 5. Okay, so first, basically what we want to do is we want to plug in numbers, right? But the only thing we need to look out for is like, obviously X, W, Y, or Z, they can't be, yeah, they must be all single digit. They can't be, I mean, if we choose like, and I'll show you in a second, but if we choose like Y equals 5, we end up getting like X is like 15 or something. So obviously that can't be true. So we need W, X, Y, and Z to all be single digit. We also need W, X, Y, and Z to all be positive, right? We can't have like a negative number for a digit. So I mean, those are kind of the two things to keep in mind. Okay, so I mean, we can kind of just go about this, by first just kind of playing with these equations. So I mean, we can say Z equals, Y plus 1 minus 5, right? Because I'm just substituting in for W. It's Y minus 4. So now we have this, and we can just say, okay, so W is Y plus 1. So then X is, I'm just putting everything in terms of Y because it's just easier to see everything that way. We can easily kind of check our answers. Okay, so, and see if like, oh, it's 1, 2 digits. So X is, W, which is Y plus 1, and then plus Y, and then plus Z, and Z is Y minus 4, right? So we get X is 3Y minus 3, right? Okay, great. So let's, since all of these depend on Y, let's start picking a value for Y. So what if Y is 0? Let's start at 0. Right. Well, so if we choose Y as 0, then X is going to be, 3 times 0 minus 3, so X is going to be negative 3. And we can't have a negative number for a digit, right? Great. Okay. So then what about if we choose like 1? Well, again, that's going to be, okay, so X is going to be 0 then. If we choose Y as 1, then X is going to be 0. But then, where's W? Sorry, wait, where did, okay, so Z, right? Sorry, Z. If we choose Y equals 1, what's going to happen to Z? Z is going to be negative, right? Okay, great. So, I mean, basically, that can't be it either, right? So what about Y equals 2? Right? Y equals 3. No. Y equals 4. Okay, let's try Y equals 4. So if Y equals 4, then Z equals 0. And then W equals, where's our W? Y plus 1. So that's going to be 5. And then X equals, basically, yep, 9. Good. And that works, right? They're all single digit. None of them are negative. And I mean, we can go up and keep plugging numbers, but once we plug in Y equals 5, then this becomes like 2 digits, right? So, and that can't work either. So we get this, and then if we just put them all in a number, if we order them now. Okay, so W equals 5, and then X equals 9, and then Y equals 4, and 0. So that's our number. Okay. All right, so let's go to 17. Do people have trouble with 17, or was that okay?
Yeah, I can do that one.
So you couldn't do that one?
Yeah.
Okay. So this one just kind of takes a bunch of hand wavings. I mean, not hand waving, but you kind of gotta look at it visually and write stuff. So notice, the one thing we want to notice is like what they're saying about the lengths. And they say it's not drawn to scale. So if we redraw it, they're telling us, right, that They're telling us that C, D, D, E, and E, F are all 10.
Right, their picture doesn't show that at all.
I know,
That's
the
not
picture
even
does not
good.
show it at all. So we have these, and then basically they also tell us that these are equilateral, right? So what do you think this side is?
Oh, okay, so it's 20.
Yeah, so this is 20, and then, this is 20, right? So what do you think we can say about maybe these sides?
So they're both 10.
Yeah, I mean, so that's kind of the leap of faith. And again, you could prove it and spend, 10 minutes of your SAT time, on the test proving it. But instead, I mean, I think it's just good to kind of assume that it's 10, right? It's metric, it's, doing all this stuff. So, I mean, yeah. So, I mean, that's all we do, and we just add them up. Yep. Great. Okay. Awesome. So let's go on. Oh, so let's go on to 18. 18, all right, so now here's our other function question. Okay, so we've got this g of x, and they tell us that it's, k times x plus 3, x minus 3. So, and then so now they give us this crazy looking thing, g of a minus 1.2 equals 0. So, and that's kind of a crazy thing, but let's not worry about that right now. For what, when is g of x going to equal 0?
The x and
Yeah, and then looking at this equation, what are those? Or you could look at the graph too, actually. I mean, either works. No, you're close. I mean, not y, but
yeah, x
yeah, exactly. So x equals either
3 or negative.
Yep. And does that make sense to everybody? Like, if we plug, first of all, if we just look at the diagram, they kind of, they mark it like this. So we see that it intersects, where y is 0, right? It's at this point right here, y is 0, right? And it's also x is at -3, or, same thing here, x is at +3. So we can look at the diagram, or we can look at this equation, right? Because, like, if we just remember, like, kind of like foiling and like quadratic equations and stuff, you guys are probably in like algebra 2 right now, maybe? Okay, good. So, I mean, basically, if we remember that, like, x plus 3 times x minus 3 equals 0, then either x plus 3, that quantity needs to be 0, or x minus 3 needs to be 0. So then x is, 3 or -3, because, 3 will make this part 0, -3 will make this part 0. Okay, good. And then, 0 times anything is 0. Okay, great. So now we have all this information. And so this is kind of the scary part, right? But we know that the thing is, I mean, for g of, I mean, what if, what if we just called like a minus 1.2? What if we just called that some variable like w? So say g of w equals 0. What does w have to be? Yeah, exactly. It's got to be 3 or -3. Great. So, I mean, then all we do, if w is 3 or w is -3, then we just say, like, 3 equals a minus 1.2. We just set them equal like that. And then, if we add 1.2 to both sides and stuff, a equals 4.2. Yeah. Yep, so I mean, this is a hard question. This is a function question. It's got a lot of steps, but you just kind of, walk through it logically. Oh, where does this function, where is y 0? Okay, let's do some, stuff. So, I mean, it's just a lot of kind of playing around with it and kind of trying to see, where you can go next. Okay, great. So we have about, 8 minutes. We'll just go over some. So does anybody like have any particular questions in section 8?
Yeah, I wasn't sure if you problem number 8.
Okay.
This one for the
Sure.
and the powers.
Sure, yeah, okay, great. I mean, did anybody have trouble with like 3?
I don't even know what those little things mean.
Okay, okay,
Yeah.
sure.
That was hard.
Okay, sure. So this is another thing, and this is another trick the SAT likes to pull. But basically, they'll give you like a funky symbol question, and they'll say, like A scribble B is like A plus B. So then what's like 5 scribble 2? And so you have to say, oh, okay, A scribble B is A plus B, then 5 scribble 2 is 5 plus 2. So I mean that's just the whole like principle behind it.
Okay,
So I mean,
so basically it's irrelevant, the whole symbol.
yeah, so the whole symbol is just something they're making up. I mean, I don't know if you guys took any like, IQ or standardized tests when you were younger, but like sometimes they'll be like, oh, the word blah blah blah, some like gibberish word, means this, or they'll use it in a sentence and they'll ask you like what the meaning is or something. So it's the same principle. Okay. So I mean when they say like, box A, B, C equals A to the B plus AC minus plus minus AC plus C, right? Then they're basically just, if they're saying what is the value of 526, they're just saying, okay, let's pretend, in this equation, A equals 5, because these are the two top ones, B equals 2, and C equals 6. So that's all they're saying.
The first one will be 5 squared then?
Yeah, exactly. So this is going to be 5 squared, and then minus 5 times 6 plus 6. So I mean, that's it. You're just going to look at like, oh, this A is the first one, 5 is the first one. Let's, plug in 5 for A. I mean, that's pretty much like all you're doing here. And so they're just trying to intimidate you by giving you like a funky symbol, and they want you to be like, I don't, they want like kids to look at it and be like, oh, I don't know what a column and like with 3 boxes like this is. I'm going to skip it. But they're just, making it up as they go. Okay, so number 8 you were saying, right? I think 8's a good one to go over. Okay. Whenever you see an exponent problem, expect like a simplification trick. So we have 3 to the 2x plus, times 3 to the 2y, and that equals 81. So we want to simplify this as much as possible. And it might, and in other ones there might be some sort of simplification like trick that you have to do. But in here, we're just going to try to simplify this first, this right side of the equation. So, and if you guys remember exponent rules, like these two, you're adding the exponents, right? Because like essentially what we're doing, just to give you kind of a big picture of where I'm going, like we want to put 81 with like in a form of like 3 to the something, because then we can like play around with the exponents more easily. So, okay, so we have 3 to the 2x times 3 to the 2y equals 81. So then 81, what is it? That's 9 times 9, right? Mm-hmm. Which is 3 times 3 times 3 times 3. So this is 3 to the 4th.
Then you just focus on the exponents, just make it 2x.
Yeah, so I mean, now, if we remember when two things are multiplied, right, then you add the exponents. So this is essentially 3 to the 2x plus 2y equals 3 to the 4th. So, and that's, now it becomes like simple, right? That you're just going to say 2x plus 2y equals 4. Yep. And then always look back at what they ask for, right? Mm-hmm. So they're asking what's x plus y. So what's the value of x plus y?
2.
Yep. Great. So then always expect some sort of, trick, right? 9 is pretty easy, but since it's a function question, let's just look at it briefly. Did anyone get that one right? Number 9?
I did.
Okay. Okay, good. So just to go over it really quickly, they're saying we have this graph, and for what value of x does the function, f attain its maximum value? So where do you think, where do you think its maximum value is? Like,
Where the slope, where the line is the highest.
Yep, it's just where it like reaches the highest. So I mean, it's just like right there. That's the maximum. So then to find the x value, what do we do?
I just do a line straight down.
Yeah, so I mean, whenever they're asking for the x value of a certain y, we can just like drop a line down here and look at where that corresponds to. And I mean, here it corresponds to 5, 1, 2, 4. 3, 4. Yeah, 1, 2, 3, 4. Okay. So I mean, this corresponds to 4. So then, you know, you're just counting the like tick marks at that point and finding where. Yep. Okay. Great. Any other questions that people had trouble with in particular? Like we probably have time for like one more. 16? Okay.
Yeah, I'd skip 16.
Okay. So they give us this equation. Okay. So this is a function. And you know, what other information do they give us? They say, you know, k is a constant, and this represents the number of bees. On what number day was the number of bees in the hive the same as it was on day 10? So what we want to do is first, like, you know, just kind of look at what the expression is for the number of bees on day 10. We say n of 10, and then we're just going to put 10 every place where t is. So we've got 10 squared over 2 minus 20 times 10 plus k. So then, I mean, again, so we don't know k, but that's actually going to be okay. So let's just like, you know, kind of simplify this a little bit and then leave it alone for a second. So 100
So
squared over 2.
200.
That's negative 150 plus k, right?
Yep.
Okay, great. So, you know, that's our expression for the number of bees at day 10. So now they're asking, you know, for some new, I don't know, number of bees at some day t that we don't know yet. And so again, that's right now, that's just going to be the same thing. And we're going to equate them, right? Because they're saying the number of bees on day 10 and this new day that we don't know, they're equal, right? So 2t squared over 2 minus 20t plus k equals negative plus k. So I'm just equating them, right? So is there anything we can cancel out now? Like, this is our equation, right? We have t squared over 2 minus 20t plus k equals negative 150 plus k. Yeah, if we just subtract k from both sides, so we don't even need to find k. We can just subtract k from both sides. They go away. And now we can just, you know, now it becomes a matter of, now we have t squared over 2 minus 20t, and we can bring this 150 over. So plus 150 equals 0. And now what we just want to do is, like, factor this. But, I mean, this is kind of hard, so it's better to use quadratic formula. Do you guys remember quadratic formula? No? No? Okay, so quadratic formula, again, you won't see that many questions. Like, you might see, probably a question like this shows up, like, every other SAT exam, but it's a good thing. I mean, quadratic formula is a good thing to know. So that's basically just a way to solve for values of, like, t or x, you know, when you have, like, a t squared plus something, t plus something. And it's just, like, it always works. I mean, a lot of times if it's simple, you can factor it. But I mean, if you have something crazy, a 1/2 over here and a 20 and 150, I mean, it's going to take you like 5 minutes to factor that, right? And that's going to like take a lot of your precious SAT time. So, you know, then we're just going to do, this is the quadratic formula, by the way. So, and this is, you know, equals t. And it actually turns out, once you solve this, you get like, you know, 10 and 30 basically. So the answer is 30 days. Yep. All right, so I mean, we're about out of time. Right, it seems like, you know, you guys are kind of, you know, doing well and holding your own weight and kind of just pushing through, so that's great. And yeah, you can just, like, if I didn't cover any questions today that you were confused about, you can always just send me an email. Because I know we can't cover, like, every single question in 1 hour. So, yep.
Cool. Thank you.
Yep, you're welcome.